We are now going to discuss anti-malware, which is software that has been designed to identify, detect, and remove malware. So the basic action of anti-malware and antivirus is to detect malware, protect from it, as well as remove it. We have two different types of scans available. So the first one is on-demand scanning. So this is when the user specifies the anti-malware or the antivirus to start. So this is user-triggered scan. And the user can specify whether the scan needs to be done for all the files on the system or just specific folders or even specific files. The second type of scanning is called real-time scanning. In this type of scanning, the anti-malware is always loaded in the background. It is running as a service in the background. And whenever you open files, you execute files, the anti-malware basically intercepts your request before executing or running that file. It quickly scans that file to identify if it is infected or not. And if it detects a problem, it immediately triggers an alert. So this is called real-time scanning. And in order to have effective protection on your systems, you should employ both on-demand scanning, which you should do periodically, as well as real-time scan, which should always be there in the background. There are two different types of malware detection techniques, signature-based and anomaly-based. In signature-based malware detection, what basically happens is that we have signatures or patterns of malware. This basically means that every malware performs some specific tasks. So for example, one particular malware, it may infect a particular segment of the memory, or it may access specific files in your operating system, or it may modify some registry entries. So based on those patterns, these signatures are defined, and we have online sources which have a listing or a database of these signatures. So what the anti-malware software does is that they periodically download these signatures, and then they compare the signatures against the scanned files on your local system. And if there is any match, and the match doesn't even have to be perfect, it can even be a partial match. So if there is a match, it basically triggers an alert. The second type of malware detection technique is called anomaly-based detection. Now this technique does not rely at all on signatures. What it does is that it creates a baseline of the normal behavior of your system. So what this means is that it creates a pattern of normal usage, which means that you know which are the operating system files which are normally loaded in memory, what are the services that are usually running, which segments of registries are basically modified as part of a routine process. Once it has that baseline, it then detects any behavior which deviates significantly from this normal baseline. So for example, if it observes a software which is opening unnecessary ports, or it's modifying parts of operating system which has nothing to do with its functioning, then this can be considered as an anomaly and may trigger an alert. You may be wondering, what is the difference between anti-malware and antivirus? Generally speaking, both are the same species of software. There is, however, a subtle difference. So antivirus usually addresses traditional or established threats. So basically, whenever you're addressing an established threat or a well-known threat which has been there for a number of years, then usually the software is called antivirus. So anti-malware generally refers to software that basically targets new and emerging threats. But generally speaking, they're both the same family of solutions. Let's start with the signature-based anti-malware. Now this type of a software, it basically downloads virus definitions and then matches file patterns against those virus definitions. So what happens is that we have several repositories on the internet which have some pre-built databases containing virus definitions, which are basically patterns or indicators of compromise of a virus. So they identify key actions or key code structures of the virus. So signature-based anti-malware, they simply fetch these new virus definitions periodically from the database, and then they match the locally scanned files against these virus signatures in order to detect the presence of malware. Now this type of anti-malware is pretty effective when you're dealing with malware that is publicly known or which has existing virus definitions available. But it cannot detect if the virus is polymorphic, which basically means that it changes its own source code, or if it is a modified form of an original virus. because then the pattern or the functioning of the virus and the code segments of that virus would be different from the definition. Now, how different is a subjective thing. So basically, anti-malwares are designed to detect presence of even partial matches. So it doesn't have to be 100 exact match, but if there is significant deviation, then of course it will not be able to detect it. The problem with signature-based anti-malware is that it completely fails when we are dealing with unknown viruses. So these are the viruses which are completely new in the market and they don't have any signature files available. So basically, they can very easily bypass signature-based anti-malware software. The second category of anti-malware uses anomaly-based detection techniques. They're quite different from signature-based anti-malware because they don't rely on the detection of signatures in viruses. So what they do is that they first create a baseline of your system, which basically is the normal behavior of applications and other services on your system. So once they have this baseline, if they detect any anomaly or significant deviation, then they can trigger or flag that application as a virus. Now, examples of abnormal behavior include accessing or modifying operating system files or components. So any legitimate software, it should not be extensively modifying operating system files or components, especially those that are not directly related to the functioning of that application. Or sometimes the viruses open ports unnecessarily, which are not even required for their functionality. So these are two big telltale signs based on which anomaly-based detection works. So the anomaly-based anti-malware software, what it does is that it basically observes the actions of the malware and how they modify operating system files or if they are opening ports. And this observation is done for all the different applications and services running on your system. And if a significant deviation is found, then this triggers an alert. Now, anomaly-based anti-malware works very effective against unknown viruses. Of course, there would be some strains which would still escape detection, but eventually a good solution is a hybrid one. You should always combine signature-based as well as anomaly-based detection. And modern state-of-the-art anti-malware softwares, they always have both the components. They have a signature-based component which basically relies on rich databases of known viruses and their variations. But they also create a baseline and they try to detect abnormal deviations or significant deviations in case there is a virus which does not have its signature in the virus definitions. So when you combine both the things, you have a pretty decent solution. Let's see how malware remediation works. So the first step that you need to do once you have detected the presence of malware on one of your systems on your network is to immediately isolate it from the rest of the network. There's no point in leaving an infected system connected to your backbone because this can cause secondary infections and the malware may spread throughout your network. So the first step is always to isolate the infected systems. So once the systems have been isolated, you may try to repair the infected files. Now this depends on a lot of factors: the significance of the damage, the type of malware that has affected it, and whether the file is repairable or not. Sometimes removing an infection is not possible. In this case, you may need to quarantine the file, which basically means putting it in a sandbox or a safe folder where it is not allowed to execute or be used on the operating system anymore. The next step is to determine the root cause. So you see, when you detect a malware infection, this may just be an indication or a symptom. It may not reveal the actual root cause, where the malware infiltrated your network from, and how it infected different systems in your network. So you need to perform a detailed root cause analysis to identify how the malware infiltrated your network. This is also important because if you just treat the malware on some of the infected systems and you do not identify the root cause, this may lead to subsequent infections through the same route. Once malware has been removed and treated or quarantined, you need to patch and update your operating systems and applications. So usually malware is a consequence of a vulnerability or weakness in your operating system or one of the applications on your system. So you need to patch and update those. Also, you need to recover from reliable backups. So let's say there was a server or a system which was extensively infected. So even if you have treated and removed the malware from that server, you can still never be sure. It's always a good idea to recover it from a reliable backup. And the last step is follow up. You may need to rescan the infected systems once again and other systems which may be in the vicinity of the infected systems, just to be sure that there is no further or subsequent infections occurring. So this is the complete life cycle of how to remediate infection. You start with isolating the system, then you treat the infection, then you determine the root cause, then you perform recovery, and finally you do a follow-up. So taking backups is still your best bet, because once a system has been infected, you would always have doubts about the reliability of that system or the integrity of the data on that system. So recovering from a trusted backup is always a 100% secure solution. You can also use firewalls. So firewalls are your first line of defense. So for example, in Windows, we have the Windows Defender, and in corporate settings, you obviously have commercial firewalls like Cisco and Juniper. Another important tool in the investigation for root cause analysis are firewall logs. So they're very useful in both detection as well as in the remediation activities, because they provide a detailed footprint of the different traffic sessions. They can give you insights into how the malware infiltrated your network, what are the IP addresses used, what were the ports used, or which website resulted in the drive-by download, and so on. And obviously, you should always employ state-of-the-art and very effective anti-malware and antivirus solutions. There are several commercial solutions available from McAfee, Kaspersky, and so on. So identifying, detecting, and treating malware requires a multifaceted approach. You need to employ multiple security tools and techniques in order to address this very serious problem.